Hi. Well, today we're looking at three special product patterns in algebra functions and graphs. We want to be able to look at those three patterns and be able to recognize them first. And then once we see them, we know a shortcut in how to handle that. So the first pattern is called a sum and difference. You have two binomials and they look almost identical, like 3t plus 4 and then 3t minus 4. They almost look exactly the same. We have a sum and we have a difference. Well, if you recognize that pattern, the product of that is very, very simple and quick. Again, if you don't remember or recognize this pattern, you can always multiply like we learned how to multiply last week. But if you do recognize it, then this pattern can easily be multiplied in a quick way. What you do is take that first term, which is the same as the term in the other one, and square it. 3 squared times t squared. We're going to square that first time. We're going to take the second term then, and notice that they're the same. It's just one has a plus and one's minus. We're going to also square that, so that 4 becomes 4 squared, or 16, and there's always a minus sign in between it. That's the product. That's how you multiply that special pattern. If you recognize it, that's a quick shortcut in recognizing that pattern. The second pattern that I'm demonstrating for you today is called the square of a binomial. So not only do you have the exact, it's not like you have a sum and difference, they are exactly the same. You have a 3t plus 4 times a 3t plus 4. That's its square times itself. Well, the pattern of that, again, you can multiply those out in the long way and do it the long way. But if you recognize the pattern and can memorize this, the way that you do it is going to end up with a trinomial. And that trinomial is built this way. You're going to take that first term, and again, you're going to square it. Then you're going to have a middle term, a linear term. And the way to get that is you multiply the two terms together and then double. Write that down. You're going to multiply 4 and 3t, getting 12t. And you're going to double that to get 24t. The last term is that the 16. We're going to be able to square that, and then that 4 squared is going to be your last term. That's it. Recognize this pattern, know how to multiply it in a quick way. The third and final special product that I'm showing to you today is titled the cube of a binomial. That binomial, if we have one binomial and we want to be able to cube it, let's use the same binomial, except we're not squaring it. We're not to have a difference, a sum and difference. We have it cubing. So you have to recognize that. When you see that, the pattern to be able to multiply it is this way. There are already 3 terms. It's a little more confusing. But you're going to take that first term, 3t, and you're going to cube it. 3 times 3 times 3, and t to the 3rd power. You're going to end up with 4 different terms in this pattern. So here's how you build one of the middle terms. You take these 2 terms and start combining them. You're going to multiply it by the power. That's going to be one of the products. You're going to take one of the terms in the binomial and you're going to square it, and then you're going to multiply it by that other term. To get that 3rd term, you're going to do a different, same type of combination, but just a little bit different. Instead of squaring this 3t term, you square the other term. So again, we're going to have 3 as a factor. We're going to have 3t as a factor. And we're going to have 4 as a factor, but we're going to square that 4 because we didn't square it in this term. So that's how you get that 3rd term. That last final 4th term, you take this other term that you didn't have and we're going to cube it. So 4 to the 3rd power. Now you just clean up that arithmetic. You now know how those 3 special products can work. You have a sum and difference, shortcut. A squaring a binomial, shortcut. You have a cubing of a binomial, shortcut. Now you can do it too. We are the Ask Academy.